The next topic that we are going to discuss is Amazon DynamoDB. Okay, so we'll be understanding what is DynamoDB, what is key value data, use cases of DynamoDB, its core components. We'll be talking about partitions over here, which is a very important component on understanding that how DynamoDB is efficient and how it stores the data in backend. Though we do not maintain this or we do not manage this, but it is very important aspect of understanding. We'll be talking about capacity and the scaling, that how we can scale our DynamoDB and what is the capacity, right? We'll be talking about consistency options. So we do have two consistency option over here, strong and eventual. We'll be discussing about both. And lastly, we'll be discussing about global tables. So these are all the modules which are really very important these are all the topics, not the module, which are very important to discuss and understand about DynamoDB. So what is DynamoDB? It is nothing but a fully managed non-relational database on AWS. Okay, what are the features of DynamoDB? Its performance, no servers to manage, and enterprise ready. So it is because managed service, right? We do not have to worry about the infrastructure management. Here also we have two options. Okay, we have the option of provisioning on demand, DynamoDB, and we have something called as provisioned. So if you go with the provisioned configuration, you have to tell that how many read capacity units and how many write capacity units you want. If you go with on demand, it will automatically scale up and down. And this is enterprise ready, that it can be worked into the production workloads as well. It can be used in production workloads as well. Right? So basically, DynamoDB is useful when you are talking about gaming, when you are talking about financial platforms like stocks, right? When you are talking about IoT data, all of these are the use cases for DynamoDB. It stores the data into key value pair. So that brings us to another topic, that what is key value data? So key value data is a type of NoSQL database that will store the data in the collection of key and value. Now it doesn't mean that, only one word key and one word value would be there. So each key value pair can consist of a unique key, and that can be used for retrieving associated values. So I can have key as let's say ID equals, I have key for ID, okay, and the value of it is 1. And with that, I can have multiple values associated, like the name of that ID, the city, the PIN code or mobile number, right? So with one key, we can have multiple values associated with it. So these key value databases are highly scalable and they can handle large amount of data. So when you want the data to be accessed quickly, as I told you already in the introduction, that when you want millisecond latencies, okay, or even I can go with single digit millisecond latency, okay, then at that time you can be using the DynamoDB. If you want to further lower it down to microsecond latency, then also it is possible by using some caching mechanisms. So this is often useful. You will be seeing the key value databases in the web applications where we want to store the user sessions, where we want to cache the data and other non-critical data that needs to be accessed quickly. It is also used into gaming applications where we want to store the user profiles or the game data, into IoT applications, or into the e-commerce store as well for creating the product catalogs. The example of key value data is over here. You can say user ID is my key, and along with that we have multiple values associated, right? So in the language of DynamoDB, each row is called as item and each column is called as attribute. Okay, so we can have multiple attributes and we can have multiple items as well. So what are the different use cases in which we can use DynamoDB? So you can use it for advertisements. So yes, that is not edtech, that is ad tech. Okay, so it is usually used or preferred in edtech platforms to store and process large amount of targeting data. So we have the ads, like if I have gone through, let's say, any kind of e-commerce website, like on Amazon.com itself, if I am seeing some kind of t-shirts, right? Now those t-shirts ad would be popping up always on my screen, right? From here and there on any application. Because nowadays we see the ads according to our interests and behaviors, right? So DynamoDB is used for storing that targeting data. It can be used for gaming data. Nowadays, we have online gaming, right, in which we do have the live leaderboards. There, we need high scalability and we also need one mechanism to handle sudden spikes. We want the lowest latency possible. So, in that case as well, DynamoDB can be useful for storing the player's data, game state, any other information like leaderboards, etc. The next use case can be IoT. So if you want to store and query the IoT data such as sensor reading, device telemetry, other time series data, I will suggest to go with the time series data. If you have the time series data, to go with the time streams database that we have on AWS. Okay, though DynamoDB can be useful over here, but time stream would be a more appropriate choice. Then we have the e-commerce websites. So suppose we have the product catalogs, user profiles, transaction data, anything as such. So those data can be stored into the DynamoDB. Why? Because it is scalable, it can handle sudden spikes of traffic, and it gives us fast and consistent performance. So that will also ensure seamless user experience over here. The next use case can be social media. Generally, whenever we talk with social media, we go with the graph databases nowadays, but DynamoDB can also be used for storing the user profiles, activity feeds, any other kind of data using different consistencies, right? You can go with the eventual consistency over here, basically, if you want. So this will allow us to quickly access the data, which is critical for delivering a responsive user experience, right? We want a good user experience. That's why we want our backend structure to be working fast. And then we have financial services. So financial services application basically stores the transactional data, account balances, any other sensitive information, or even if you have the stock trading platforms, then in that case also DynamoDB can be a good choice. It provides data encryption and other security features. Apart from that, it also provides us with a fast access of the data. So that's why this is also one of the good use case for DynamoDB. Now it again depends up to your workload and your choices, right? If you think that any other database would be working fine, generally for the financial services, we generally go with the relational databases. But if we do not want to go with relational database, we can also go with the DynamoDB if it fits our requirements. At the end of the day, it will always depend what is your requirement. How do you want to handle your workload? Okay. So now we are going to discuss about the core components of DynamoDB. So there are three core components that we will be discussing. The first is table, then we have item, and lastly we have attributes. So we have already discussed this into the example, but let us try to understand this again. So the DynamoDB is a database system that stores the data into the tabular manner. It doesn't mean that it would be following the fixed rigid schema just like we have in our relational databases. So with each table containing multiple items, okay, each item containing one or more attributes. So what I told earlier, that when we have the table, okay, each row is called as item and each column is called as attribute. So each item in a table represents a unique set of attributes. So it is not compulsory that each item would be having, 5 attributes over here. Some items might have 4 attributes, some might have 3, some might have 1. It depends. For example, if we have people table, okay, let's say this is people table. What attributes it can contain? It can contain ID, it can contain last name, it can contain first name, phone number, right? City. So these are the different attributes that we have for our people table. Similarly, if we have table for cars, it can contain items representing different vehicles, and attributes can be make, model, year of car manufacturing, color of that car, what is the horsepower, Newton power, etc. Right. So these are the core components. We already can see it over here. We have this employee table. So employee is our table. We have how many attributes over here? 5 attributes. Employee ID, first name, last name, phone, city. And we have 2 items over here. So items are nothing but the collection of attributes, and table is nothing but the collection of items and attributes. The next topic to be discussed about is partition, which is really very important. So, what are partitions? Partitions are basically the tiny table in which the data is being stored in the backend in DynamoDB. And because we do have the partitions and we have the concept of partition key, that's why DynamoDB is really very fast. How will this work? So basically, when we talk about partitions, okay, then DynamoDB supports the partition first of all to distribute the data across multiple servers to provide fast and reliable access. So the entire table that we have would be divided into different partitions. Okay, so what are these partitions? These are the units backed by SSDs. Okay, so in the backend we have the SSDs in which our data is being stored. Our entire table would be divided into small partitions and they would be replicated across multiple availability zone, making it highly available. So DynamoDB would be automatically handling this partition management. But how it will decide that which entry or which row will go to what partition? So that would be decided using the partition key. So whenever we are creating the DynamoDB, we have to select the primary key for our DynamoDB. Now primary key are of 2 types into DynamoDB. Okay, the first type of primary key will have only one attribute, and that attribute would be our partition key. Okay, and the other attribute that we'll be having for this particular primary key, that can be the combination of partition key and sort key, right? So this is how the primary key will be decided. If you think that partition key can be unique for the entire table, then only partition key is enough for your primary key. If you think that the partition key might have duplicate values, then you can use the combination of partition key and the sort key for uniquely identifying your item inside of the table. So whenever you would be creating a new table, okay, DynamoDB would be allocating enough number of partition to handle the amount of throughput that you have provisioned. So whatever throughput that you are provisioning for your particular table, that throughput would be divided into those small partitions. Okay, so during the initial creation stage, the table status would be creating. So once this is, why this is creating, why the state would be creating, because we need to allocate enough partitions. And after the partitions have been, allocated, the table will change to the active state where you can start reading and writing the data into the table. So we have to choose the partition key over here, and the partition key will be deciding that to which partition our data or that particular row would go to. On this partition key, some hashing algorithm would be applied, and accordingly our data would be distributed. So when we are choosing the partition key, we have to ensure that it evenly distributes the data across the partition. Okay, so we need to ensure that each partition is roughly the same size and there is no hotspot partition which is significantly having more data than others. We have to avoid using a partition key with a small number of distinct values because this can lead to uneven distribution and cause performance issues. If we need to query the data across multiple partitions, we can use Query API with a partition key value and a sort key value. So this will allow us to retrieve all the items that match with partition key and the sort key criteria. Another important thing while deciding the partition key is all your queries would be running on the basis of partition key, okay? Means if you want, just try to understand that what kind of queries are coming. If you think that your queries are coming, let's say that I'm having a note table into which I have note ID, I have student ID, I have note, and I will mark whether it is favorite or not. So over here you can see that note ID can be 1, 2, 3. Student ID, let's say student A, student A, student B, student C, student C, and student D. This is suppose my table. Okay, and there is some note, let's say A, B, C, D, E, F, I, J, K, X, Y, Z, P, Q, R, L, M, S. These are the notes that we have. And we can say favorite yes, no, I don't have any value over here. I have yes and other two values are null. Because this is NoSQL database, I can keep these nulls, right? So what do we have to do over here is note ID generally will not be used for invoking the queries. What kind of queries I can have over here? I can have the query that what are the notes created by student A or what are the notes created by student C. The count of notes created by student A. How many favorite notes are being created by student A? So I'm seeing that student ID is being repeatedly used in my queries. So I would be making this as my partition key. Because this is not unique, okay, it is having the repeated values or duplicated values. That's why I'll make my note ID as sort key. Right? So what will happen when I'm making partition key as student ID? There would be 4 partitions created in the backend where one partition would be storing the data for student A, all the records of student A, all the records of student B, all the records of student C and student D. If you try to imagine it over here, when I try to say that give me all the notes created by student A, then instead of going through the entire table, this is a very small table that we have taken as an example. But in real life, the tables are really very huge, having tons of data inside of it. So if I want to find all the notes created by student A, then instead of reading the entire table, it would be great if I just go to the partition, if I just hit the partition of student A and I collect all the data from there. right? So that's where partition key comes into the picture. It is very helpful in the query performance in DynamoDB. Sort key would be helpful for sorting the data as the name suggests. So all the data would be sorted according to the sort key. So if you think that you want to create multiple partition keys or different kind of sort keys and partition keys, then you can use the concept of indexes. There are two types of indexes that you can create over here: local secondary index and global secondary index. We are not going in the depth of these two, but yes, indexing is what you can use if you think that you want to use or you want to have multiple combinations of partition keys and the sort keys. If you think that you want some other partition key and the sort key apart from that of table, then create one different index for it. And you can also query your indexes. That will help you make your performance more efficient. Now we will be talking about DynamoDB capacity and scaling. So there are two capacity modes of DynamoDB: on demand and provisioned. So on demand and provisioned capacity mode. Let us discuss this first of all. Before I go to this, okay, I have to discuss about the read capacity unit and the write capacity unit. So whenever you want to specify the capacity of your DynamoDB, then you have to specify that how many RCUs and how many WCUs you want. What is RCU and WCU? If I talk up in the figures or numbers, then one RCU would be equivalent to 4 KB of read per second. So you can read 4 KB of data per second if you have provisioned your table with 1 RCU. The next is WCU. So if I have 1 WCU, then it means that I can write 1 KB of data per second. So let's suppose that I have provisioned my table with 10 RCUs and 5 WCUs. So that means that I can read 40 KB of data per second and I can be writing 5 KB of data per second in my table. Okay. So this is about RCUs and WCUs. Let's take one more example over here just to make the things clarified. Okay. Suppose I have one DynamoDB table inside of which I have 3 items, or say 2 items. One is the header. Okay. So let's suppose this is my one item is of 2 KB. Okay. Each item is of 2 KB size and I have provisioned 1 RCU for my table. Then I'll be able to read both of these items, right? Because 1 RCU means 4 KB of read per second. So in 1 second, I can read both of these items if required. And if I want to write a new item over here in this table, okay, which is of 2 KB, then I'll be requiring how many WCUs? 2 WCUs, right? Because 1 WCU is equivalent to 1 KB of write per second. So for writing 2 KB, I need 2 WCUs, that is 2 KB per second. This being clarified, let's now go to on-demand capacity mode. So on-demand capacity mode is a feature of DynamoDB that provides flexible pay-per-request pricing for read and write. So it is flexible billing option. You will be only paying for the data that you are reading and writing against the table. No provisioning is required. Okay. From beforehand, I'll not say that I need 10 RCUs and 10 WCUs. I don't have to tell this. It will automatically, according to demand, change my, you know, RCUs and WCUs. So we are not paying for any idle resources or idle capacity unit. And we are also not missing out any opportunity because it will scale in and scale out automatically. So we don't have to specify or reserve the capacity in advance over here. It will automatically scale up, scale down based on the actual read write request volume that it is getting. So because of that, we do not have to pay for any upfront cost or any minimum fees. This would be specifically useful when we have the application with unpredictable or spiky workloads, as we can avoid over provisioning the capacity and wasting the resources during periods of low activity. Some of the key features that we can think about on demand capacity mode is automatic scaling of read and write capacity based on actual request volumes. We are paying per request with no upfront or minimum cost. Ability to handle spiky workloads. Ability to switch between the on demand and provision mode at any point of time. Supports all DynamoDB feature including global tables, streams and backup. And here also we have the ability to monitor the usage and the performance using the CloudWatch. So overall, on-demand capacity mode can be cost-effective, flexible option for many DynamoDB workloads, especially with those which have unpredictable or spiky traffic. It may not be the best choice with the application which require consistent traffic volumes or strict performance requirement, or where I want to understand that okay, this much of bill I would be getting monthly. So here the bill would be changing according to the request that we are getting. If I want the predictive bill, then this would be not a good option for me. So if I want such, predictive things, then what other option do I have? So for that, we have the provisioned capacity mode. It is the feature of DynamoDB that allows you to specify the read capacity units and the write capacity units for your table. So you would be specifying RCUs and WCUs to handle your expected workload. To use the provisioned capacity in DynamoDB, you specify read capacity, write capacity, and you can adjust the capacity later as and when required. Whenever you are specifying your provision capacity, okay, it will evenly distribute it across the partitions into your table. Suppose you have said that I have 100 RCUs and 100 WCUs, and you have 4 partition according to the partition key. Then each partition would be having 25 RCUs and 25 WCUs to it. So it will evenly distribute the provision capacity across your partitions. That's another reason of avoiding the hotspots in partitions. Okay. By provisioning the right amount of capacity, you can ensure that DynamoDB can handle the expected traffic without experiencing throttling or any other performance issues. But that would always not be possible. Okay, I cannot always specify that okay, I would be always using 25 RCUs or say 100 RCUs and 100 WCUs. What if I am using less of these, or what if I want more? Okay, I want to scale out. So this also provides us with the functionality of auto scaling. Okay. So you can say that, okay, minimum of 100 RCUs I want, but maximum it should go or stretch up to 1000 RCUs. So by that, you would also not be throttling your incoming requests. So what are the key features of provision capacity mode? You have control over the amount of capacity you provision. allowing you to optimize the cost as well as performance. It is good for predictable workloads. It uses auto scaling to automatically adjust the capacity based on usage patterns. It supports global table, streams, and backup. And this also have the ability to monitor the usage and performance using the Amazon CloudWatch. So these are the different features and the functionalities that we have for our DynamoDB capacity modes. The next topic that we are going to talk about is DynamoDB consistency options. So there are two types of consistency models over here. As you can see, we have eventual consistent reads and we have strong consistent reads. So eventual consistency is a consistency model which is being used by DynamoDB to provide high availability and scalability while minimizing the latency and the cost. So eventual consistency, as the name suggests, your table would be reaching into a consistent state, but after some time. Eventually it will. So this will reduce the cost. Okay. In eventual consistent systems, the changes to the data are propagated asynchronously, which means that, and where the consistency options would be coming into the picture, where you have the read replicas, right? When you are dealing with replicas, then these consistencies will be coming into picture. So different replicas of the data may not be in the sync. Suppose I have three replicas A, B and C, then A, B and C, all of these must not be having the same data. They must not be in the sync if we are using the eventual consistency. So in eventual consistent read, you can expect some stale data. If you repeat your read request after a short time, you might get a different response. Okay, the next is strong consistent read. So when you request a strong consistent read, the DynamoDB returns the response with the most up-to-date data, reflecting the updates from all the prior write operations. So eventual will not, it will be asynchronously copying the data or replicating the data between replicas, and strong consistency would be replicating synchronously among the all read replicas. The next topic that we are going to understand is global tables. Before we go to the global tables, I have one more important topic to discuss, which is about scaling. Okay, so let's take one blank screen over here. So we have three different types of scaling over here. We have scheduled scaling, okay, we have dynamic scaling, and we have predictive scaling mode. So global tables, it is a very important and a crucial feature of DynamoDB where you can have the replicas of your DynamoDB tables across multiple AWS regions. Now these replicas are not just the read replicas. Your application can access these tables which are in sync with each other, having the same data globally with low latency. So this support both read and write operations. So with global tables, you can create a fully replicated multi-region database that will provide low latency access to your data from anywhere in the world. So DynamoDB will automatically handle the replication of data between your different global tables. You have to define the primary region where your table is being created, and then you can add one or more replica regions to the table. So DynamoDB automatically replicates the data from primary region to replica region so that all the copies of the table would be having the same data. Even the table names are same. Okay, just the regions are different. You can write to any copy of the table and those changes would be propagated to all other copies in the backend. So what are the benefits of this global table? So the first benefit that we could think of it as multi-region access. So you can access the data from anywhere in the world. Okay. Let's suppose that your primary region is somewhere in India and you do also have the customer base in USA. So instead of traffic traveling from USA to all the way to India for accessing that database, okay, what if we have one replica in US itself? So the round trip time and the latency would be reducing drastically over here. You have improved availability. So by replicating the data across multiple regions, you can have improved availability of application by providing failover capabilities in case of region outage. If one region is going down, you have your database up and running already into your other region. It simplifies your data management. With global tables, you can manage your data in a single database and have it automatically replicated to multiple regions, reducing the need for complex data synchronization process because it is being handled by backend via DynamoDB. You do also have built-in conflict resolution. So global table provides built-in conflict resolutions capabilities that automatically resolve conflict that arises when the data is updated in multiple regions. So global tables are well suited for applications that require low latency, multi-region access to data such as gaming, mobile, IoT applications, etc. By replicating your data across multiple regions, you can provide high availability, low latency databases that can handle changes in traffic or workload while minimizing the downtime and the data loss. So these are the features of global table that we have. And this was the last topic that we had to discuss for DynamoDB as well. So the entire database topic is being covered. We have started talking for this particular, module. We have started with what is database. We understood the difference between relational and non-relational databases. We talked about the RDS service and its features. We have seen the demonstration for it. We have talked about DynamoDB and its features. And now it's the time to do the demonstration for DynamoDB and understand it well enough. So let's go to the portal and try to understand the DynamoDB as well. So I am onto my AWS console, right? I want to create the DynamoDB. I have to search it from here and I also have that into my recents. So let's go to DynamoDB from here. I am into the North Virginia region and we can create a table from here. Okay. So let's just click on create table. If you are not seeing this screen, okay, then you can also go to left hand panel and you can go to tables from here as well. So you can see we have our tables over here, but I do not have any tables in this account in this particular region. So we can create a table. So here also the deletion protection feature is being there. Just like RDS, you can also have deletion protection for DynamoDB, which ensures that we do not accidentally delete our database. So we have to enter the table name. Let's say I will just say sample table. The partition key. Now you can see that this is the compulsory parameter that we have, but the sort key is the optional thing that we have. So let us say that I'll be creating that same notes table. Okay, I'll just put student ID as a partition key and I'll just make it as a string. I'll keep it as string and I'll say sort key as node ID and I'll be making it as number. So do you want to build the set table with the default settings? This is the fastest way to create the table with most best practices being used over here. Or the basic table settings are being there. Or you can also customize the settings. So let's go with the customized thing. You have the two classes for DynamoDB. So just like we have classes in S3, we do have it over here as well. So DynamoDB standard and DynamoDB standard infrequent access. So standard would be always used when your data is frequently accessed with, you want high throughputs being delivered. It would be also on the higher cost end, right? Then you have DynamoDB standard infrequent access, where the tables that are being stored, okay, that are not being frequently accessed. So here the cost will be reducing. You do have capacity calculator integrated over here. So you can see that what would be the estimated cost if you are putting, what is the average item size and what are the read and the write capacity units you want. What is the capacity mode you want? On demand, if you select this on demand, you will not see read capacity unit and write capacity unit. Okay, so it will be, you would be paying for the actual read and writes, the requests that are coming to you. We have already discussed this. So I'll just go with the provision mode. Do you want auto scaling to be on for read capacity? So yes, I want it on. The minimum read capacity unit is 1. The maximum it can scale up to 10. When it will scale up to 10, or when it will scale up when the target utilization is up about 70%. When already capacity units that I have, those are being utilized till 70%, then we would be adding more capacity units. Same as with write capacity unit, the auto scaling is on with minimum write capacity unit 1, maximum of 10 with target utilization 70. You can create the indexes over here, the local secondary index or the global secondary index. We can discuss this, at the end. After this, we can also discuss about these two indexes. What are these? How they are different. Okay, we'll be discussing that. So this is the estimated read-write capacity mode cost. Okay. So do you want to have the encryption at rest? So if so, what is the encryption technique you want to use? Do you want the key which is being managed by DynamoDB or by AWS KMS, or you want to have it stored in your account, owned and managed by you? That is your customer key. So I'm good with DynamoDB managed key. I want to turn on the deletion protection over here. I can add the tags, but these are optional things, so I'll avoid it and I'll create the table. So you can see the status of this table is creating. It means that it is creating enough partitions in the backend for handling our provisions. Okay, that is one being the lowest read capacity and write capacity, and 10 being the highest. So now you can see the table status is active. It means that the partitions are being allocated to us. So if I just go inside of this sample table over here, you can see the general information. Partition key, sort key, point in time recovery is off. You can make it on if you want. Capacity mode is provisioned. No items are there. That's why the item summary is 00. These are some charts where you can see the matrices. Apart from that, I can just go to the indexes. Right now, we do not have any indexes, but we can create. But now we will see that we can just create global secondary index, because local secondary indexes are only possible to create when we are creating the table. After that, it is not possible. Okay. We can have the monitoring over here. If you want to create some alarms, you can create it. We will be checking what are alarms and metrics in our next modules. Global tables, we do not have any replicas over here. If we want to create the replica, we can simply click on create replica. Okay, into which region you want to create the replica. So let's say I want to go with the Canada region over here, and I will create the replica. So what will happen? Two databases would be there in sync with each other. One with North Virginia region, that is the current region or the primary region. The secondary region would be the Canada region. So this is the Canada region where the status of table is being creating. Do we have any backups? No, so we do not have any backups as of now. You can create the backup if you want one. You can have also point in time recovery where the continuous backups are being taken for DynamoDB table for 35 days to protect you against the accidental write or the delete operations. It would be having additional charges to it, obviously. If you want to export the data to S3, you can do that. You can turn on the Kinesis data streams to DynamoDB. So it will capture all the item level changes in your table and will be replicating the changes to the data stream, that is Kinesis data stream. You can have DynamoDB streams, so it will capture item level changes again in your table and push the changes to the DynamoDB streams. Then you can access the change informations through API. If you want to create any triggers for invoking the Lambda functions, then also you can do it over here, but I do not want that as of now. The last is additional settings. What are read capacity, write capacity units? You can always edit that. If you want any auto scaling activities to be done according to some metrics, then also this can be done. Some items can be deleted from the table automatically after specifying TTL. You can change the encryption methods. Deletion protection is on, and tags we haven't given any. So after we go through all of these settings, we can explore table items from here. So you can see we have two options, scan or query. Okay, so when we go with query, it means that our query would be hitting one of the partitions. If we go with scan, it is the expensive operation because it is going to scan the entire table instead of querying a particular partition. Right, so we do not have any items over here. Let's create one item. What is the student ID? Let's say student A with 1. I will add a new attribute with string. The value for that would be note and ABC and create the item. I'll create another item. I'll put again student A. Okay, now see if I try to put 1 over here and I'll put another attribute for note that says DEF, and if I try to create the item over here, it will give the error. Why? Because we have partition key and the sort key as primary key, and student and 1, this entry is already there, so you cannot have duplications in the form of primary key, right? So I'll just put it over here and I will create the item. I'll create last item over here just to make you understand certain things. So I'll just go with student B and the node ID over here I can put 1. Okay, because then it would be having a unique combination again because the student ID is being changed now. It is no longer student A, it is student B. So that's why I will put XYZ over here and let's create the item. So we have student B with note ID 1, student A with note ID 2 and 1. Now I will run a query. So you can see that query is running against the partition key. Scan would be running on the entire table. Query would be running on a particular partition. So if I want to get the answer that what are all the nodes created by student A, okay, so I can have it over here. Let's run the query and we have the details of student A. So it will directly hit the partition of student A and it will return the value. So it will be really very fast, right? So this is all for DynamoDB demonstration, guys. You can just, explore here and there and you can understand the importance of DynamoDB over here. That's it for this demonstration. With this demonstration, we come to the end of our module, that is the database module. So that's it for the database module as well. Thank you, everyone.